Hello, in this video we'll be going through my free Unreal Engine beginner course, which will cover all of the fundamentals of Unreal that I think everyone should know. First we'll go over how to install and navigate around in Unreal, and then we'll cover the most commonly used features so you have a good understanding of how to use Unreal Engine to create custom systems that you want. To get started, head over to the Unreal Engine website and download the Epyx Games Launcher by clicking on this button right here. Once you've installed the Epyx Games Launcher, head over to the library section, and if you don't have Unreal Engine version 5, just click this button, and then from here, select Unreal Engine version 5 and install it. Once you've installed Unreal Engine 5, simply just click this launch button, and it should take you to a page looking like this. If you've made previous projects inside of Unreal Engine 5, you'll be able to easily access them here by just clicking on them and then opening them. Although this is a beginner tutorial, and we're going to go over how to create our own projects. So to do that, you want to head over to the game section, and there are a bunch of starting templates that you can make your project start with. Although in this tutorial, we're going to make our game start with a third person template, so just select this, and then we want to give our project an appropriate name. So I'm going to call this project Beginner Project, and then click Create. Once your project loads, it should take you to a scene like this, and this is the Viewport tab. And the Viewport tab basically shows you everything inside of your level. One of the most important things you're going to need to be able to do in Unreal Engine is move around your viewport and view the different objects in it. So let's go over how we move around inside of Unreal Engine. You can move your camera around by holding the right mouse button and then just moving it around. Kind of like how you would move like if you're playing a first-person shooter game. And then you can use the WASD keys to move the actual position of your character. And then as an alternative way of moving, you can also hold the middle mouse button and move it up and down and towards the left and right if you want to move like that. And let's say you want to zoom into a specific object inside of your viewport. What you can do is select it. So if I select this cube and then click the F button, it will zoom me in to where that cube is. So those are how you can kind of like move around inside of the viewport. Next, let's go over how we can manipulate objects inside of Unreal Engine. So let's say I wanted to move this cube somewhere else in my level. To do that, we basically select the cube with our left mouse button, and it'll become highlighted in yellow. So any object that we select will be highlighted in yellow. And we can see these 3 little arrows. And these 3 little arrows basically represent the directions we can move our cube in. So if I hold this blue arrow, I can move my cube in the Z-axis, up and down. If I hold this green arrow, I can move my cube in the Y-axis, so towards the left and right. And if I select my cube with this red arrow, I can move it in the X-axis, so I can move it backwards and forwards. And we can also move our cube in 2 axes at once. Do you see these 2 little lines between the Z arrow and the Y arrow? If I just select them, they both go yellow. And if I just select them again, I can just move my cube in the Z and Y axis at the same time, without moving it in the X axis. And we can do the same here. So if I just select it here, I can move my cube in the Z and the X axis without moving it in the Y axis. And we can also specify how much we want our cube to move by. So we can do that by changing its grid settings. So right now the grid setting is 5. And that basically means every time I move my cube, it'll move by 5. But we can change this value. So if I just change this to be, for example, 500, every time I move my cube, it's going to move by 500 units. So you can just use that to specify how much you want to move your cube by. Now, as well as moving our objects, we can also rotate them. So to rotate them, we just select this, select and rotate objects icon, and we can see that our gizmo kind of changes, and we can rotate our cube in the Z-axis, the Y-axis, and the X-axis. And just how we can specify how much we want to move our cube by, we can also specify how much we want to rotate our cube by. So if I just go here, I can make it so I can rotate my cube very precisely. So I can change this to be a smaller value like 5, and I have much more control over the rotation of my cube. And there's one final way that we can manipulate our objects, and that is by scaling them. So to do that, we just click the scale icon, and we can scale our cube in, again, all axes. The Z-axis, the X-axis, and the Y-axis. And we can also specify how much we want to scale our object by. So to do that, we can go here and set our scaling option. So if I made this 10, if I try and scale up my cube in the Y-axis, it's going to move by a lot. So I'm just going to change mine back to 1. And there's one more thing we can do with scaling. So if I select this other cube, we can make it so that we can uniformly scale our object. So if I just select the middle icon and then hold my left mouse button, I can make it so that this cube scales in all its axes evenly. So basically, using those tools, we can manipulate objects inside of Unreal Engine. Next, we're going to go over how to use the Outlier tab. The Outlier tab will show us every single object inside of our level. So, for example, if I select this cube, it will now become highlighted in my Outlier tab. And if we double click on something on our World Outlier tab, it will zoom into that object. We can also hide objects using this tab. So if I click this eye icon, it will now hide that selected object. And inside of this tab, we can also create folders. So if I just go to this folder, if I just click the eye icon, it will hide everything inside of that folder. So I'm just going to click it again and we can re-see it. And to create our own folders, what we can do is we just select this map and then click this add folder button. We can create a new folder and I can call it example folder. And let's say I select this cube and drag it into my example folder. Now if I hide the eye icon on my example folder, it's going to hide everything inside of that folder. So we can just use the World Outlier tab to see all the objects inside of our level. Next, we're going to go over how to use the details panel. So if I just select an object, it will now appear highlighted in my details panel, and we can manipulate the transform of any object that we've selected. So here we can change its location in the X, Y, and Z by just moving around these values. So I can just move around this slider and it will change its value. We can also type in values here. So if I made its Z value, say 90, it's just going to be 90. And we can do the same with its rotation and its scale. If you wanted to make it so that when you change the scale of an object in the details panel, that it's uniform, what we can do is just click this anchor icon. And then let's say I change the value to be 3. It's going to scale it uniformly by these settings. But if you don't want that anymore, we can just uncheck this. Depending on the object we select in our details panel, will depend on the options we can change. Because I've selected a static mesh, there are a couple of settings I can change. So I can, for example, change the static mesh that I want this to be. I can change it to be a chair. I'm just going to change mine back. And I can also change the color that I want this to be. So for example, I can change this to be this color. But let's say I selected a different object, like this text render actor. If I scroll down here, I can change different settings. So I can make this say a different text, like example. So depending on what we select in our details panel, there'll be different options that we can change. We are now going to go over how to use the content drawer. So if we just click this little button here called content drawer, we'll be able to access all the blueprints and objects inside of our Unreal Engine project. So I can double click and go to this level prototyping folder and go to the meshes, and I'll be able to see all the meshes inside of this folder. And if I simply just select one of them with my left mouse button and drag it here, I can now place where I want this inside of the world. So we can use our content drawer to access any objects or blueprints we've made. We can also create blueprints inside of our content drawer and then place them in the world, although we'll be going over that later. A quick way to access the content drawer is to use Control Spacebar, and that will just bring it up. If you want your content browser to always be displayed, what you can do is if we head over to this window section and then select content browser and then select content browser 1, and it will always be there. So I can just move this up, and now the content browser will always be there if you want it. And if you don't want it there anymore, you can just click this close minor tab and it will remove it. While we're on the subject of tabs, you can also rearrange how the tabs are. So for example, if I select this outlier tab, I can move it here, and now my outlier tab will be here. But I can also move it underneath here, and it will become underneath here. So you can just play around if you want to like change how your Unreal Engine 5 looks. If at any time you mess up the layout of your project, you can always go to Window and then go Load Layout and then select the default editor layout, and it will take it back to the original layout. In Unreal Engine, there are many different ways that we can view our level. I'm going to go over the main different ways that I like to do this. The first way we can view our level is the current mode we're in, which is lit, and this will kind of just show us our level, how it's going to be when our game's exported. The second way we can view our level is if we change the viewing mode. To do that, we want to go over here, click this button, and then change it to unlit. And when everything's in unlit mode, there'll be no shadows and every color will be flat. This makes it easier for your level to load. So this is helpful if you're running Unreal Engine on, say, an older laptop, or if you have a very big level. It could be quite laggy if it's in lit mode. If you change it to be unlit, it'll help Unreal Engine kind of run smoother. And then the final way we can view a level is if we go to wireframe, and as the name suggests, it'll make everything wireframe. And as well as having different view modes for our level, we can also view our level from different angles. So to do that, if I just click this perspective button, we can also view our level from the top, bottom, left, right, front, and back. So for example, if I just click this top button, I'm now going to be able to view my level from the top. And I'm just going to change this to be wireframe, and that's a bit easier. So this is kind of helpful if you're like designing a level. We can just select, for example, this bit, and maybe I can move it. We can view it from the front, from the back. So you may want to just use these different modes when you're designing a level. I'm just going to change it back to perspective. So we can just use Unreal Engine to view our levels from different modes and perspectives. This can help with level designing or just making it easier for your machine to run Unreal Engine. Next, we're going to cover a feature which we'll put into Unreal Engine, which allows us to easily import high quality assets into your project. So to do that, what you want to do is head over to this little plus icon to quickly add things to the project and click Quixel Bridge. It will open a page looking like this, and you want to log into this site. You can do this by clicking on the icon on the right and clicking sign in, and then you can log in with your Epix Games account. Once you've logged in, we can browse loads of assets which we can easily import to our project. So I'm going to go here to 3D assets and click on the food, and I'm going to click on this cucumber. And what we can do is we can just drag this cucumber here and drag it into our project. And if I just click F, it will import that cucumber into our project while it downloads in the background. So if I just go here, we can see that this is starting to download in the background. So models normally come in 3 qualities. So you have medium, low, and high. And if you like any assets and don't want to download them now, what you can do is click this heart icon. And if you scroll down and go to your favorites, it will have a list of all the favorite assets that you've hearted. And if I just close this, in my content browser, if I go to my Megascans folder, it's going to have a list of all the Megascan assets which I've downloaded into my project. In Unreal Engine 5, they introduced a new feature called Nanite. Nanite helps improve the performance, rendering, and loading of models inside of your Unreal Engine project. In order to enable it, simply just select the model that you want to enable Nanite for, then select Ctrl-B. This will take us to where the model is located inside of our folder. Double-click on the model to open it up, and then in the details panel, there should be this Nanite settings. Simply just check this Enable Nanite Support, then click Apply Changes, and now Nanite is enabled to our model, which should help its performance. And if I zoom out of my model with this Nanite mode enabled, my model is going to have less detail. However, if I zoom into my model, the model is going to have more detail, and this Nanite will just help the performance of the model inside of my game. I'm just going to go back to my normal view mode. So it's recommended that you should use Nanite on models which are quite high poly and have lots of triangles. And if you place a model many times in the scene, so if you have like this model multiple times in the scene, again, it's recommended that Nanite is enabled just to help with the performance of the game. Hello. Next, I'm going to go over how you can create a blueprint. So if we press Ctrl Space to open up the content drawer, head over to the blueprints folder, and to create a blueprint, just right click and select blueprint class, then select actor. Call this BP_example. If we double click and open it up, inside of our blueprint, there are a couple of different tabs. I'm going to explain what each of them does. So the first tab we have is this components tab, and this allows us to add meshes, collisions, and components to our blueprint. So for example, I can just add this sphere and it'll be added to my blueprint. The next tab we have is this viewport tab, and this visually displays how our blueprint is going to look. And then the final tab we have is this details panel tab. If we select one of our components, it will load up all the details that we can change within it. So for example, with my sphere selected, I can change its scale, its rotation, and even its material. The next tab I want to show you is the event graph. Here inside of the event graph is where we write what will happen to our blueprint when it's inside of our game. We write what will happen to our blueprint using nodes. Nodes are these little boxes that we see here, and different nodes will perform different actions to our blueprint. So we just drag in our sphere, and just drag off here and look for set material, and just select the brick material. If we hook this up to the event begin play node, the way this will work, As soon as the game starts, it'll fire this node. So if I just go compile and close this, if I drag in my BP example blueprint, we can see that it is this white sphere. However, if I click the play button, as soon as the game starts, my BP example will run the event begin play node and make it so that my sphere will turn this brick color. So here inside of the event graph is where we're going to write most of the code for our blueprint. The next tab I want to show you is the construction script. The construction script is helpful for initializing / loading up things that we want to happen inside of our blueprint before the game has even loaded. So if we go back to our event graph and if we just break the link here, if I just copy this node and paste it inside of my construction script and just hook this up here and go compile, we can see that before the game has even started, my sphere has turned this brick color, and that is because we set up this node inside of our construction script. If I just broke this and go compile, we can see that my sphere will be white. However, if I hook up some nodes in my construction script, it's going to load all of the events before the game has even started. In this next section, we're going to go over variables. Variables are properties that hold a value or reference an object or actor in our game. We're now going to go over how to create a variable. But before we do that, if we just select this blue cube, scroll down and go to its color, just select this search button and just press Ctrl C and paste this material 2 times. For the first one, double click and open it up and just select base color and make it green. We can close this and just open up the second material and make it red. And just call this material mi_green and call the second material mi_red. Then if we head over to our blueprint sorter, open up the BP example, and we can just delete what's inside of our construction script. And if we go over to the event graph, then if we go over to the variable section, just select this button and it will create a new variable. Just call this Boolean example. And if we go over to the variable type, we can see there are loads of different variables inside of Unreal Engine. But we want to make sure that we select the Boolean variable. And if we just go compile, this should load. And with a Boolean, we can determine whether this variable is true or false. So it should appear as this little box here. If I check this button, then that means the Boolean is true. If I leave this blank, then that means the Boolean is false. So I'm just going to show an example of how this will work. I'm just going to delete these 2 nodes. And if I drag in my Boolean example, we're going to look for get Boolean example. And this will allow us to read whatever this value is. Then we just want to drag up here and look for the branch node. The branch node is commonly used with the Boolean variable. And if we just hook this up to event begin play, depending on whether our Boolean is true or false, we're going to do certain things to our blueprint. So if our Boolean example is true, then we're going to drag in our sphere and set its material to be that mi green material that we just made. So I'll hook up true to here. However, if this is false, then I'm going to copy this, paste it here, and I'll make it so that my sphere will turn red. So I'll look for my mi_red, and I'll just go compile. For now, let's just leave this unchecked. And if I go over here and change this to be simulate, it will simulate how the game will run. And as you can see, as soon as the game starts, because my Boolean variable was false, it changed my sphere to be red. However, if I just left this variable checked, so I'll just select it and check it, then go compile. When I load my game, the sphere will turn green. So we can use Boolean variables to determine whether something will be false or true. There's something else I want to show you with variables. We can also make them instance editable, and that way we can change them in the game. So if we just check this box, this will make the variable instance editable. I'll go compile, and if I close this and make another sphere, so I'll just select Alt on my keyboard and that will duplicate the sphere. If we scroll down, we're going to see we have this default tab, and this allows me to control the value of this Boolean. So I can just leave this unchecked, but for this sphere, I can leave it checked. And when I go simulate, one sphere will be red, one sphere will be green. So by making variables instance editable, we can control the value of them inside of our game. When working with booleans, there are also a couple of other nodes that we normally use. So I'm going to show them now. If I just drag off here and look for and boolean, and I'm just going to create another variable and call this boolean example 2, and we just break the link here, and if I hook this up to here, in order for our sphere to turn green, 2 booleans are going to need to be true. So if I just drag in my boolean example, and I'll also make this instance editable. In order for a boolean to turn green, it will need to have this boolean to be true and this boolean to be true. I'm just going to delete this. There's also another boolean node, so we can just drag off here and look for the or boolean. And the way this works, core node, as long as either one of these conditions are true, then it will turn my material green. We can change the value of a boolean variable inside of our game by just dragging it in here and looking for set boolean, and we can just check this, and if I just hook this up here, as soon as the game starts, it would make sure that my boolean variable became true. So we can use the set node to control the value of variables. I'm just going to delete this and hook this back in here. And then there's one more boolean node example I want to show you. If I just delete this, if I just drag up here and look for not boolean and connect this into here, and the way this not node works is it will do the opposite of whatever is inside of my boolean variable. So if my boolean example is true and we run this not node, it will do the opposite of this. So it will turn my material red. However, if this boolean example is false, it will do the opposite and turn my sphere green. So now if I go compile and close this, for this one, if we leave the boolean unchecked, it should turn green. And for this one, if we leave the boolean checked, it should turn red. So if I go simulate, that one becomes green and that one becomes red. With our variables, we can also categorize them, which will help them be a bit more organized. So I go back to my BP example and select my boolean example variable. If we go to category, if I just type in a name like example, this will put my boolean in the example category, and I can just select my boolean example 2 and drag it here, or you can just select this little box here and choose what category it will go into. If we just compile this and close this, if we select our BP example, we should see this tab called example, and here it will list all of our boolean variables. So you can just put variables under categories if you just want to be organized. So the next variable that I want to go over is the integer variable. So if we just delete all this boolean stuff that we made, and if we go to variables and create a new variable and just call this integer example, and under variable type, if we just change this to be an integer and go compile, the way an integer variable works is an integer can hold a whole number. So it can't hold any number if it's a decimal. So if I just drag in my integer example and look for set integer, if I try and make this value like 54.6, it's just going to change to be 54 because an integer has to be a whole number. So this is helpful if you want to like track the amount of items that the player character is holding in your game, or if you want to track a player's score and you want to make sure that it's always a whole number. I'm now going to go over a node that you may use when you're working with an integer. So if we just drag in the integer example and look for get integer, what we can do is if we just drag off here and look for switch on int, and if I just delete this and add to pins and hook this into here, depending on what number this integer is, it's going to depend on what this fires. So if I make this integer 0 and hook this up here, the material is going to be green. If I make this integer 1, the material is going to go red for the sphere. So if I just copy this and make a new example and change this to be basic 4 and add a pin here and make this 2. If I make this 2, this number 2, then the sphere is going to go this color. So now I go compile and make this instance editable, so I can just change this in the game and go compile. I'll make 3 spheres by clicking Alt and duplicating them. And if I make this 0, if I make this one 1, and I make this one 2, and go simulate, they're all going to be different colors because we set that integer variable to be a different number. Next, let's go over how to use the next variable, which is the name variable. So if I just go to add variable and call this name example, if I change this variable type to be name and go compile, I can type in a name here, and the way we can use this node is if I just break the link here by clicking Alt, event begin play, I'm going to have a delay, and then let's make this delay 2 seconds, and after this delay I can look for open level by name, and then here if I wanted to I can specify this in a variable, so I can look for get name example and hook this up here. And if I just close this and open up my content drawer, so my level is called third person map. So if I just call this name variable third person map and go compile and go play in my game, after 2 seconds, it's going to open up this level again. So you can see after 2 seconds, it opens up that level. And the next variable I want to show you is the text variable. So if we just go add variable and call this text and make this variable type a text, and also check this instance editable. If I go to my viewport and go add and add a text renderer component and just move it up so we can see it, we can use this text variable to specify what we want this text to say, or we can just type it in here. So maybe I want this text to be like fish, that'll be fish. But if I go to the event graph, event begin play, I can drag in my text renderer and look for set text, and I can make it be whatever inside this text variable. If I just get this text, hook it up here and go compile and make this say I am text and hook this into event begin play and go compile. If I close this and if I go simulate my game, the text is going to say I am text, but I can also change it. So maybe I make this text say I am not text and then go simulate. So all of the other two say I am text. This one says I am not text because I specified it. And we can just use the text variable to specify what we want text to say. Next, let's go over how to use the vector variable. For this example, I just want to close our BP example blueprint that we made, and if we click Control Space, open up the content drawer and head to the third person character, we're going to create the variable inside of them. So if we just go add variable, and let's call this vector, and under variable type, just change this to be a vector. And then if we just right click and look for the 1 key, when we press the 1 button, we're going to look for set actor location, and we can use this vector variable to determine where we want to transform our character. So if I just drag this in here and look for get vector and hook this in here and click compile, I can specify specifically where in the X, Y, and Z that I want my player character to go to. So just click that little arrow in order to see that. And let's see, so this seems like a good location. 1200X, 1000Y, 150 here. So I'm just going to copy these variables and paste them inside my third person character. And now if I go compile, and I'm just going to delete this so I don't spawn inside it. And now if I go play and press the 1 key, my player is going to be moved to the vector location that we set. You can also use this vector variable to change the scale and store the size of objects. So if I go to my BP example and create a vector variable, so I'll just call this size and change this to be a vector. And actually, if we go to the construction script, what we can do is if I just drag my sphere and I'm going to delete this, we can look for set world scale 3D. And as you can see, this has an X, Y, and Z. We can just drag in our size variable. And if I just click compile and change this to be 10, 10, and 10, and then go compile, my sphere is going to have a scale of 10. So you can see it's really big. And then if we just make this instance editable and compile, we can now in real time change the scale of our object using this variable if we wanted to do that. And the next variable I want to show you is the rotation variable. So we can use this variable to set and store the rotation that we want our player character or actors to have. So I go to variables and click add variable, and I'll call this one rotation. And under variable type, if I make this a rotator and click compile, I'm just going to delete this node. And we can just drag off here and look for set actor rotation. And if I just drag in this rotation variable, I'll get up here and I'll delete this and go compile. If I go to my viewport and select my player character, we can see that their rotation is currently 270. If I just select my rotation variable, we can change our axis rotation in the X, Y, and Z. So if I make my character rotation 10 and go compile, so if I click play and I move around, let's say I make my character's rotation here. If I press 1, it's going to set my axis rotation to be 10. So we can use that rotation variable to set and store the rotation variable of actors or objects inside of our game. If we just delete this and create a new variable and call it transform, and under variable type, make sure it's transform, and if I just go compile, the transform contains the location, rotation, and scale of an object. If I drag off this pressed, I can look for set actor transform. And if I just drag in my transform variable and right click here and look for split structure pin, we can see the transform is made of the location, rotation, and scale. So it kind of can hold 3 bits of data. And to just make this go back to normal, we can right click and look for recombine structure. And if I just hook this up here and under the transform, let's say I make the scale of my actor 1.5 here. I won't change its rotation or location, though you can if you want to. And now if I click compile and click play and press 1, so my actor has become bigger and it set his location to be 0, 0, 0 in the world. That's why he was teleported there. And it also set his rotation to be 0, 0, 0. So maybe I should actually make it so his location is somewhere like here. So I'll just make it 1700 and 600. That way he doesn't spawn off the map. So make this 1700 and this 600, and I'll make this 50 so he spawns a bit in the air. And now I go compile and go play, press 1, my actor will spawn there and he'll also be a bit bigger because I made his scale a bit bigger. So those are all the main variables that you're going to probably use inside of your Unreal Engine projects. In this next section, we're going to be going over some of the basic nodes that you're probably going to end up using when you create a game inside of Unreal Engine. So let's get started. If we open up our content drawer and head over to our BP example, nodes are these events that we've been using, such as the event tick, this switch on int, this open level, this delay, and nodes allow us to perform and execute certain events. So like I said, we're going to be going over some of the basic nodes that I think everyone should know when they're creating a project inside of Unreal. So to get started, if we just delete everything here, apart from the event begin play, and the first node I want to show you is the delay node, and we used this previously, although I just want to explain this one more time as you may end up using it a lot. So if we just go event begin play and then just drag off here and look for delay. After this delay, this node is going to perform whatever is after this completed event. So if I make my duration here, after 2 seconds, it's going to perform whatever's after here. So if I just drag off here and look for print string and make this say hello, and if I go compile and go play, after 2 seconds, it's going to say, oh, whoops, I just need to drag my sphere into my world here, and if I go play, and after 2 seconds, it's going to print string hello. The other type of delay I want to show you is the retrievable delay. To showcase how this works, if we go over to our content drawer and go to our BP underscore third person character, and let's just delete anything we were previously using. And if we just right click and look for event, begin, play, and just drag off here and look for a retrievable delay. A retrievable delay will kind of work the same as a delay. However, if this delay is called again, then it's going to reset this. So let's say I have a retrievable delay of 3 seconds. And after 3 seconds, I'm going to make it print string the word hello world. And then if I just right click and press the 1 and look for keyboard events 1 and just hook this up to pressed. If I keep on pressing this 1 button, it's going to reset this retrievable delay. So this will only fire if it's not called again. So to showcase this, if I go compile and I go play, if I continuously press 1, it's never going to fire because I keep on resetting the retrievable delay. However, if I let go and let 3 seconds pass, so I'll let go now, after 3 seconds, it's going to say hello world. So it says hello world. So that's kind of how the retrievable delay is. Sometimes you may want to use a normal delay, sometimes you may want to use a retrievable delay. So the next node I want to show you is the flip-flop node. So if we just delete this and delete our event begin play, when we press the 1 button, we're going to look for the flip-flop node. So we'll look for flip-flop. And the way the flip-flop node works is whenever we call this, first it's going to do A and then it's going to do B. So to showcase how we could use this, if I just drag in my mesh and look for set material and just duplicate this, so I'll press Ctrl C and Ctrl V. The first time I press this, we're going to make it change the player character's material to be this mi_cube01. The second time we press this, we're going to make our character's material be this mi_cube02 material. And now if I go compile and go play, if I press 1, first I become yellow. If I press 1 again, then it'll go blue. And as I continuously press 1, it's going to flip-flop between executing those two different commands. So we could add different commands here, but that's basically the way the flip-flop node works. Whilst we're here, I'll also go over how the material node works. So if we go to our viewport and select my character, some meshes will have multiple materials inside of them. So you can see this character is made up of two materials, element 0 and element 1. If we head over to our event graph, we can see in our set material, we're changing element 0. I could change this to be element 1, and this will change whatever is assigned to element 1 in my player character's material. So I'll just make this 1, and now if I go compile and go play, we can see it will change a different part of the player character. So the next node I want to show you is the sequence node, and as the name suggests, it executes things in sequences. So if we go to our content drawer and go to our BP example, we can just delete everything here. And event begin play, we're going to look for the sequence node, so just look for sequence. And as we can see, the sequence node works by executing what's ever here, then what's ever here. We can easily add more sequences by clicking this add pin. And we can easily remove sequences by just simply right-clicking on any one of them that we want to remove and clicking remove execution pin. So event begin play, I can make the sphere print string, the word hello, and then maybe I can get my sphere and set its mesh. So we can look for set static mesh and change its mesh to be a cone. And then after I've done that, I can maybe set its material to be a different color, so this pink. And then after I've done that, that can be it. So I'll just right click and remove this and go compile. And if I just make my sphere a bit smaller because I made it really big. And now if we just go compile and drag this into our world, and we can just go simulate, we can see it will turn to a cone and then turn pink. That happened a bit fast, so what we can do is we can add some delays. So we can just, before we turn this to a sphere, we can add a delay of say 1 second. And then after it's executed this, we'll have another delay and we'll make this 2 seconds. And then if we go compile, and we should be able to see everything a bit faster. So it's a circle, then turns to a cube, and then turns pink. So that's how we can just use the sequence node. We can use it to execute things in a sequence. So the next node I want to show you is the do once node. And to showcase how this works, if we just open up our third person character and go to where we made this flip-flop event, if we just drag off this where we press the 1 button and look for do once, and now go compile, and if I just go play, and if I press 1, we can see I changed to yellow. However, if I press 1 again, it's not flip-flopping and changing between blue and yellow, and that is because of the do once that we added. So do once will only fire once. If you want to reset the do once, then we can plug something in here. So if I just right click and press 2, for example, and if I hook this up to the reset and go compile and go play and press 1, I'll switch to yellow. And if I press 2, it's going to reset the do once. So now if I press 1 again, it's going to change to blue. So you can just use do once if you only want events to be executed once, And if you want to reset the do once, then you can just plug in a node or something to reset this do once. Hello, so the next node we're going to cover how to use is the branch node. We did go over how to use this when we created Boolean variables, although it's such a common node that I want to show you a shortcut on how you can create them very quickly. So if we open up our content drawer and go to the BP example, we can just delete everything here. And in order to quickly create a branch node, just select the B button on your keyboard, then left click and it'll create a branch there. And just a quick recap, the branch node does what it says. So if we fire an event inside of here, if this condition is true, then it's going to fire off here. And if this condition is false, then it's going to fire off here. The next node I want to show you is the event begin overlap and the event end overlap. So if we go to our viewport and we can just delete this sphere here and the text renderer here. And if we go to the construction script, we can just delete these nodes here. And if we go to our components, we're going to look for add and look for a box collision. And then if we select this box collision, we can scroll down and we can see there are some events that we can assign to our box collision. So the most common events you'll probably be assigning to your box is on component begin overlap and on component end overlap. And we can assign some events to happen when a player character or an object overlaps this box and when they stop overlapping this box. So let's go over on component begin overlap. We just click this node. On component begin overlap, we can see there are loads of details here. We can then fire off a node when this condition is met. So on component begin overlap, I can just drag off here and look for print string. And I'll make it say hello and just go compile. And if I just drag this into my world, we can see it is here. One thing with making box collisions, if I click play, I'm not going to be able to see where this box collision is inside of my game. In order to fix that, we can just simply select it and then in details, look for hidden in game. And if we just uncheck this and go compile and go play, we should be able to see our boxes. Although we normally leave them hidden just so that we can't see them whilst we're in the game. Although once we made our final game, we can then make them all hidden again. So now if I just overlap this box, we can see it says hello. On component end overlap works kind of similarly. So if I just scroll down and go on component end overlap, once someone's overlapped this box, if they leave it, then this node will fire. So on component end overlap, I can make this also say hello, and I'll just break the link here. Quick note, a quick way to break links is if I just click the Alt button and then the left mouse button, and it'll break any link that I've selected. And now if I go compile, go play, and let's say I enter this box and then leave, it'll print string the word hello. One thing with on component begin overlap is in order for this to work, if we just scroll up, the collision of our box will need to be on overlap just so that it can overlap actors. Another event you may use with meshes or collision is the on component hit, and this kind of works the same, although this time the collision would need to be blockable. So if I just change this to be blockable, and the way this works is when something hits this box collision, it will fire off here. So if I just drag off here and look for print string, and I'll just break the link here so I just know that I'm hitting it, and I'll just change this to be hit. And if I go compile and play this, if I hit this box, we can see that I'll print string the word hit. So those are some on component events that you may want to use. The next node that I want to show you how to use is the print string node. So I normally use this for debugging purposes. So on component hit, if we want to check what our boxes hit, what we can do is just drag in our other actor and hook this up to the print string, and it will get us the name of what hit the box. So now I go compile and go play. If I hit this box, it's going to print string that I'm the BP third person character, and that is what hit the box. So I normally like to use print strings to debug things or let me know information about some of the blueprints that I've set up. Another thing we can do with print strings is we can currently see that whenever something prints strings, that the color is blue and it stays on the screen for 2 seconds. We can change that here by, for example, I could change the text color here to be orange, and maybe I only want the print string to appear on the screen for 1 second. And now if I go compile and go play, if I trigger my print string, it will now be orange, and each print string will only last for 1 second. Hello, so the next node I want to show you is the for loop node. I'm going to showcase this with an example. So we go over to our content drawer and go to our third person character. We can just delete everything that we made previously. And then when we press the 1 button, just drag off here and look for for loop. And the way the for loop node will work is it's going to fire this node however many times our last index is. So if I make this last index 5, it's going to fire this node 6 times. The reason it's going to fire this node 6 times is because it counts 0 as a number. So just to showcase what I mean in case you don't get it, I'm going to drag off this loop body and look for print string and hook up this index into here. This index basically will let us know what value of the for loop this is on. So now if I go compile and go play and press 1, it will fire 6 times, 0, 1, 2, 3, 4, and 5, because it counts 0 as a number. Once our for loop has finished firing, we can just drag off completed and look for print string and make this a completed. And now I go compile and go play. If I press 1, it's going to fire all those nodes and then go completed. So the for loop node is helpful if you want to repeatedly fire things in a certain range. Hello, so the next node we're going to cover is the timeline node. We can use the timeline node to make events happen over time. To showcase this example, we're going to create a door which will open. So to get started, if we head over to our content drawer and just right click and look for blueprint class, select an actor and call it BP_door. Once we've done this, we just double click and open it up and go to components and look for a cube and just select this select and scale objects and just make this cube kind of look like a door. Again, if we want more precise precision over the scaling of it, we can go over here and just make this like a smaller option if we want to have more control over the cube when we change its scaling. I'm just going to move my cube up a bit, and if you want to, we can right click and rename components. So I'm going to rename this to door, and the idea here is we're going to use the timeline node to make our door rotate over time. Although there's one more thing we want to do. Right now, if I try and rotate this door, it's rotating, although it's not rotating like a door would. Because of that, we're going to go to components and add another cube and just call this the door hinge. And we just want to scale this down a bit. Select the middle one to scale it down in all its axes and just put this at the bottom corner of your door and simply just drag this door and drag it into the door hinge. And the idea here is we're going to use the timeline node to make this door hinge rotate in its z-axis so we can have a door which opens kind of like this. Because if we try and rotate our door here, it doesn't rotate correctly. Quick note, you can just click Ctrl-Z to undo something that you've done if you want to undo it. Okay, so now that we've done this, let's go over to our event graph. And to use the timeline, we can just drag off here and look for Add Timeline. To create a timeline, simply just double click inside of this node and it'll open up the timeline. Then we want to go to Track and look for Add Float Track. The length here will represent how long the timeline is going to play for. Let's just change this value to be 2 and then click enter and our timeline will update. Next, we need to add certain moments along our timeline. In order to do that, just right click and look add key to curve float _0. And here we can add a node specifying its value and its time. For this example, we want to make the time 0 and we also want to make the value 0. So in our timeline, we have a node which is basically going to have a time 0 and value 0. We just want to right click and add another key curve, although we'll make this time 2. And at time 2, we're going to make this have a value of 1. To zoom into our timeline, because it's kind of got a bit messy, just click these 2 arrows and it will position our timeline correctly. Now that we've done this, we can just click in our event graph to go back, and in our timeline, we can see this new track. So this is a float track that we've made, and inside of this float track, we have 2 values, time 0, value 0, and time 2, value 1. We can use this timeline to make certain events happen. So we go back to our event graph. In order to create a door which will open over time, we're going to use another node called a lerp. So we just right click and look for lerp float. So it'll be this one, lerp float, and just select it. Now this lerp float has 3 different points. This alpha value basically represents what value the lerp is going to have. When this alpha value is 0, it's going to have whatever value a is. And when this alpha value is b, is going to have whatever value b is. If we just connect our new track into here, because we made a timeline which goes from value 0 to value 1 over 2 seconds, this is going to be the value of our alpha. So if we made this value, for example, 0, and we made this value 10, and because we've hooked it up to our timeline, if say we are at value 1 inside of our timeline, this LUT would have a value of 5. So using this, we can make our door open over the value of this timeline. To do that, we can just drag in our door hinge. I'm going to just drag up here and look for set world rotation, and just right click here under new rotation and look for split structure pin, and just hook up this value to the Z value. And then we just want to hook from update into here. Now, if we head over to our viewport and go to our door hinge, we can see that its rotation is 0 in the Z axis. If I rotate it, say, -90, we can see our door rotates to the left. So if we go back to our event graph, under here in my LUT, I'm going to make this 0, but in my B, I'm going to make this value -90. And now what this means is event begin play, over the course of 2 seconds, my door is going to rotate from a value of 0 to -90 in its Z axis. So let's just test this all out. So if I go compile, I'll just change this back to 0. I'll just select my door hinge and change this value back to 0. And let's just drag in this door into our world. And I'm just going to click simulate. And if I go simulate, event begin play, over the course of 2 seconds, our door will rotate from a value of 0 to -90. So that's how we can just use timelines to make events happen over time. And that was just one example. We can also use our timeline to, for example, make our door become bigger over time. So if I just delete this and just drag off door hinge and look for set world scale 3D. And if I just hook from the return value into here, it'll change its scale in all of its axes. And we can see that my door hinge currently starts at a scale of 0.125. So I'll just put that in the A value and hook update into here. And then in the B value, let's just change this to be 1. And now if I go compile and close this, if I go simulate, over the course of 2 seconds, my door is going to change to be a scale of 1. Hello, next we're going to go over how to create and use a function. So if I just go control space and go to my third person character, we can use functions to collapse certain node groups together, and it just makes the workflow of our project easier, and we can also call and reference functions elsewhere in our project. So to create a function, let's first write some blueprint nodes. So when I press the 1 button, let's get our actors location and move them. So to do this, let's just look for get actor location. And then when we press the 1 button, we're going to look for set actor location. Where we're going to set them, let's just drag off this value and look for add. And in the Z, I'm just going to add 250 and just connect this into here. So I can make this a function by just left clicking with my mouse. You can right click on it and then go collapse to function. And let's just call this move location. And now when I press the 1 button, it can do the move location. And with this function, I can just copy this and let's just paste it to where my player character jumps. So now if I go compile and play, if I press the 1 button, we can see that my character will move 250. And if I just press spacebar, we can see that my character will also just move up 250. There are a couple more things we can do with our function. So if we just double click and go inside, we can see all the nodes inside of our function. Next, if you select your function and go to the details panel, there is this access specifier. Right now it's set to public, and what that means is we can call this function inside of our player character, but later in another section when we go over blueprint communication, we can make other actors such as this door or another blueprint that we made. We can also make that blueprint call this function inside of our player character. However, if we change this access specifier to be private, that means we'd only be able to call this function inside of our third person character, and we wouldn't be able to call this function outside of our player character. So if I head back to my function, another thing we can do with our functions is add inputs and outputs. So if I just click this add pin, I can create a new input in my function, and I can call this location. And now if I just connect this inside of here and go compile and go to my event graph, when I press the 1 button, I can specify the additional location I'd like to add to my player character. So when I press the 1 button, maybe I'll make it 500. And when I jump, maybe I can make it 200. So we can modify functions by adding inputs if we want to change what happens inside of our function. And another thing we can do with our functions is add outputs. So if I just go here and add a new output, and I can just call this did move ? And we can see it created this return node. And if I just drag this towards the end, after we move our player character's location, I can just hook up this return value into here. And if we just compile and go to our event graph, we can see that off of our move location function, it has this did move. And I can just drag off here and look for branch. And if I successfully do move my player character, then we can just have a print string which says success. So I can just change this to say success. And now if I go compile and go play, if I press 1, it will move me up 500 units and then say success. So you can use functions to make your project a bit tidier when you're writing some nodes. There's still even more that we can do with a function though. So if I just select my function, move location, and I'm just going to modify it a bit. So if we just remove this set actor location, and on this return node, if we just change this to be a vector, and just call this final location, and if we just connect this inside of here, and move location to here, and go compile. So now our function is going to get our actor's location, plus whatever value we have here, and then it's going to output it here. So there are a bit of compiler errors because we just need to delete this, and we just right click and go refresh nodes. It will update our nodes, so I'll just do that there, and it's done that there. And now we go compile, it should be fine. So just to recap, we've changed our function just so it gets our actor's location, plus the location that we put inside here, and then it will return that value. And the reason I've done that is we can change how our function looks. So if I just select my function and just check this pure button, it will make my function look like this. So maybe you don't want connecting nodes, and we'll just get the output of our function. So when I press the 1 button, I can just look for set actor location and just hook this up here. And now I go compile and press 1 and press 1. It'll set my actor's location up 500. Although this time we're just getting the output information that we need. So sometimes you may want to have your function be pure, sometimes you may want it to be here, just depending on what you do. There's also another way that we can collapse a bunch of nodes together, and that is by creating a macro. Macro are kind of similar to functions, although there are some key differences. But first, let's go over how to create a macro. So if we just go inside our function, we can copy this bit, and we go to our event graph, paste it here, and just hook from here into the new location, and we'll just move our function. And if I just select all these nodes, I can right click and go collapse to macro. And let's just call this move location macro. If I double click and go inside this move location macro, we can see it's kind of similar to the function. There's some inputs and there's some outputs. We can just select our macro and we can add an output. So I can just click here and I can just call this execute. And then I can just hook up this node to here. Inside of my macro, I can also have variable outputs. So I can just hook this return value into here if I wanted to get the result of whether this was successful. And we can kind of just use macros to collapse a bunch of nodes together that we're working with. I can hook from this location variable to here. And I'm just going to rename this location to travel. And now if I go compile and go to my event graph, when I press the 1 button, I can set my player's location so that he's plus 250 in the z-axis, and I can just do a branch to just check whether this was successful. And if it was, we can print string the word success. So now if I go compile and go play and press 1, it teleports my character up 250 units and it print strings the word successful. So we can kind of use macros and functions to collapse some nodes. So you may be thinking, what's the difference between both of them? So with our functions, they can't perform latent actions. So what I mean by that, if we go inside our function, we can't have any delays. So if I just drag off here and try and look for the delay node, I don't get the normal delay node. However, if I'm inside of my macro, we can perform latent actions. So I can make this have a delay. So I can just drag off here and look for delay. The second key difference between functions and macros is functions can't have multiple outputs, whereas macros can. So inside my function, this is the only return node we can have. However, inside of my macro, so if I just head over to it, if say I just have a branch here, and hook this up here, I can have multiple outputs. So maybe I can add a new output, and if this is false, I can make this do output 2, and inside of my event graph, I can make this link to another node. So inside of macros, we can have as many outputs and inputs as we want. Another key difference between functions and macros is when we go over to the blueprint communication section, it's easier to communicate and reference functions from other blueprints. So if I was making this blueprint talk and call the function inside of my third person character, it's easier to do with a function than a macro, although more will be explained about that when we go over to the blueprint communication section. So in terms of advice whether to use a function or a macro, you'd mainly want to use a macro if there's a part of your blueprint where you want to basically reuse it everywhere quickly. However, it'd be best to use a function if, say, you wanted to reference this from another blueprint. The next type of node I want to show you is the custom event node. So we just delete all the macros and functions that we made last time. And to create a custom event, just right click and look for add custom event. Then it's going to ask us to name this custom event. Let's just call this swap materials. We can just write some nodes after here. And the thing with a custom event is now that we've made this, we can call this custom event anywhere else inside of our node. So when I press the 1 button, I can call this custom event. So I can just look for swap materials, and I could just paste and call this node at other parts inside of my event graph. So if I just drag off here, after we swap materials, actually I'm just going to drag in my player's mesh and look for set material, and we can set the material to be mi_red and just hook this up here. With custom events, we can also add inputs. So if I just select it and add an input here, I can add a branch called isTrue. And when I press this 1 button, I can control whether I want this variable to be true or false. Let's just make it true. And if I just drag off here and look for branch, if this condition is true when the custom event is called, we'll swap our player character's material. So now I go compile and go play and press 1, my character will turn red. And when we go over to the blueprint communication section, we can also call custom events inside of other blueprints. The next node I want to show you is the set timer by event node. So if we just delete everything inside of here, and when we press the 1 button, just drag off here and look for set timer by event. And there are a couple of things here. First off, we have the return value. We just want to right click on here and promote it to a variable and just call this timer event variable. You'll see why this is relevant in a second. Next up, we have the event. To create it, just drag off this event and look for add custom event. Let's call this custom event swap colors. Next off, we have the time. So this is going to be how long it takes to execute this event. So let's make it 3 seconds. And then next off, we have looping. And if we check this, this means when we call this event, it's going to do it every 3 seconds. If this isn't looping, then it's going to only do this event once after 3 seconds. For now, just keep this checked. And let's just drag off here and use the flip-flop node. And the first time this event is called, we will swap our player character's colors. So I'll look for set material, and we can just turn them red. And then I'll just copy this. And the second time, we can then just turn them mi_cube01 and go compile. And now let's go play. If I press the 1 button, it's going to launch that custom event. And every 3 seconds, I should be swapping colors. So first I'm red, then after another 3 seconds, I'll be yellow, then after another 3 seconds, I'll be red. So that's how we can kind of use the set timer by event node. Although maybe you want the timer to eventually stop running, that's why we created this variable, timer event variable. And if I just right click and look for the 2 button, we can make it so that when we press this 2 button, it will stop this event. To do that, if we just drag in our timer event variable, look for get timer event variable, and just drag off here and look for clear and invalidate timer by handle, and just hook this up here. And I'm just going to make this happen a bit more frequently, so 0.5 seconds. And now if I go compile and go play, if I press 1, every 0.5 seconds, I'm going to be changing colors. However, if I press the 2 button, it's going to stop that set timer by event from running. So again, we can just use that set timer by event if we want to have an event which happens multiple times, or you can just have it once, but that's basically how you'd use this node. There's also another type of timer node event that we have. So if I just drag off here, when we press the 1 button, we can look for set timer by function name and just click enter and break the link here. And this kind of works the same as the set timer by event, although this time we can call a function to run on our timer. So if I just right click here and promote this to a variable and call this timer event 2. And if we just create a new function, so we already made one, but let's create a new one, go add, and let's just call this function timer, and then every time we call this function, let's make it say the words print string and print string hello, and we'll make this orange. And if we go back to our event graph and go to the function name, if we call it timer, so this is important, the function name needs to be exactly the same as how it's typed here. And then under time, let's just make this 2 and check this looping. When I press the 1 button, it's going to call this timer function every 2 seconds. And if I want to stop this timer from running, let's just go over to our 2 key and drag in our timer event 2 and hook this up here. And we can delete this and go compile and go play. And now if I press 1, every 1 second, I think I made it, or every 2 seconds, it will start print stringing the word hello. If I press the 2 button, it's going to stop that timer. So I press 2, and now that timer event should stop running. So that is basically how you can use the set timer by event node and the set timer by function name node. Hello. So there's one more thing I want to show you in regards to nodes. If we just open up our BP door blueprint, with our nodes, we can double click on any part of them, and it will create a reroute node. And this just basically allows us to make our node look a bit cleaner. So I can move my node here if I wanted to, or like here. And again, you just use this if you want to like tidy up how your nodes look. And the final thing in regards to nodes, if I just delete these two, what we can do, just so we can stay organized and remember what nodes you've made, we can just select every single node and then click the C button, and we can comment a node. So I can maybe call this open door when the game starts. And then if you want to, we can change the font size of this. So if you want it to be really big, and you can change the color of this. So maybe you want this node to be red. So we can just use these two handy tools to keep our nodes organized. Hello, in this next section, we're going to be going over all the different ways we can make blueprints communicate with each other. To showcase my first example, if we just right click and create a new blueprint class and select an actor and just call this BP_cube. If we head inside this blueprint and under components, just go add and select a cube. And if we just select this cube, scroll down and change its collision presets to be overlap all. And if we scroll down and just click this on component begin overlap, the first blueprint communication method I want to show you is casting. Casting is a blueprint communication method where you reference an actor, and if you reference it successfully, you'll be able to reference any information inside of it. With casting, there's only communication between the current actor and the actor you're trying to cast to. In case that didn't make any sense, I'm going to show you an example of what I mean now. So if we just right click and look for cast to the BP_third person character, we can drag off this as BP third person character and reference all the variables inside of him. So if I just drag off here and look for vector I can get and also set the vector variable that we made inside of our player character. So just scroll down and look for set vector. If you don't remember, inside of our third person character, earlier we made a bunch of variables, and using the casting communication method, we can reference and change any variable inside of our third person character. In order to successfully reference and change anything inside of our third person character, we need to make sure that we're casting correctly. So with our cast, we have an object. With our object, we need to get a reference to our third person character. So if I just hook this up to my cube and hook this into here, if my third person character overlaps this cube, then I'm going to be able to make a reference to my third person character and change something inside of here. So if I just go to my third person character and we have this variable called apples. If you don't, just create a new variable and make it an integer and just call it apples. I'm just going to delete this. And when I press the 2 button, I'm going to get the amount of apples I have and print string it on the screen. So I look for print string and just connect this into here and go compile. And let's make this start at a value of 0. However, if my third person character overlaps this cube, then as my third person character reference, I'm going to set the amount of apples they have to be a value of, let's say, 5. And if I just connect this into here, and we can delete these nodes and go compile, close this, and let's just drag in this cube here. And if I go play, if I press 2, it will print string 0, so I have 0 apples. However, if I overlap this cube and now press 2, it will now say 5 because I have 5 apples. So I'm just going to delete the other blueprints that I made because they're taking up a bit of space. And if I go back to my BP cube, that's kind of how we can use casting, although there's a bit more that we can do with it. So if I go back to my third person character, let's say I create a function. Actually, we already have a function called timer. With casting, it allows us to easily reference functions. So if I just drag off my third person character, I can reference the timer function I made by just looking for timer. And let's say my player character overlaps this cube, I can just easily call this function. Although let's say I try and reference a macro inside my third person character. So we made one called move location macro. If I just drag up here and look for move location, there is no move location macro. So remember earlier in the last section, that's where you may want to use functions if you want it to like communicate with other blueprints. So let's just create another function and call it change colors. And in this change colors function, we can just get our mesh and set its material to be a different color. So I'll just make it this blue, hook this up here and go compile. And when my player character overlaps this box, we'll cast to them and look for the change colors function and just hook this up here. And I'll delete this and go compile. And if I go play, go here, when I overlap that cube, I will change colors. So we can just use casting to easily communicate with one blueprint to another. So one important thing for casting, in order for it to work, it needs to have a valid object reference to the thing it's trying to cast to. So if it didn't, then this cast would fail. So I'm just going to showcase an example of that. If I just drag this off here and look for print string, and I'll make this say failed. And if this is successful, I'll print string this and make it say success. And if I just break the link here, and for the object reference, if I just dragged up here and made this self, so we can make objects get a reference to themselves. If I just want to compile, we can see it's already warning me that this will fail because this self-reference cannot cast to the third person character. But if I just tried it and went play and overlap this cube, we can see that the cast will print string failed because it failed to cast. So in order for a cast to work, it needs to make sure it has a valid object reference to the thing it's trying to cast to. One more thing with casting, we can also quickly cast custom events. So if I go to my third person character and right click and look for add custom event, and let's just call this test. And we can hook this up to our print stringing of how many apples we have. And I'll go compile, go to my cube, and I'll just reconnect this here and delete this. And I'll just delete these 2 nodes. And if I just drag off here, I can quickly reference my custom event by looking for test and go and compile. So with casting, you can quickly reference custom events and functions. So my project just crashed, so I just remade my BP cube. Last time we made it so that this cube has a collision preset of overlap all, and when our player character overlaps with this cube, we'll cast to our player character and then call some custom events. An alternative way of giving our cube collision is just by going to components, and we can go add and look for collision. And there are three types of collision: box collision, capsule collision, and sphere collision. If we just select box collision, and we can use the box extent or the select and scale objects to fit our box around our cube. And if you scroll down, just make sure that your box has a collision of overlap all dynamic or overlap all. And like I said, this is just an alternative way of giving our box some collision. With that, we can close this and go on to the next section. Hello, the next Blueprint communication method that I want to go over is the Blueprint interface. And this basically allows our Blueprint to communicate with whatever has this Blueprint interface. So let's go over how this works now. If we just open up our content drawer and right click and go Blueprints and select a Blueprint interface and just call this BP underscore interface. And if we double click and head inside here, we can see it has six functions. Just create a new function and call this interact. And we just compile and save this. And if we just head over to our BP underscore cube and go to class settings and under interfaces here, just go add and add the BP interface that we just made. And now if we go compile and you go to the section called interfaces, we should see that interact event that we made in this BP interface. So now in some free space in my event graph, if I just right click and look for event interact, and it should look something like this, we can now call this event interact from other blueprints. So let's go over how to do that now. If I just close this and go to my third person character, and if I select this capsule collision and scroll down and go on component begin overlap, we're first going to check to see if this other actor has an interface. To do that, we can just drag off here and look for does implement interface. And the interface we're going to be checking for is the BP interface. And if this condition is true, so I'll just left click and select B. If this is true, then I'm going to call the interact event. So with interfaces, we don't need to do any casting. We can simply just drag off this other actor and call the interact event. So we want to look for this interact message. And now when my player character overlaps another actor, if it has this BP interface, it's just going to call that interact event. So inside of our cube, let's make it so that when we overlap this cube, it destroys this actor. And go compile. If say I just duplicate this cube, so I'll just press Ctrl C, Ctrl V, open it up, and let's make our cube green. When I interact with this cube, let's say we will make our cube bigger. So I'll just drag in my cube and look for set world scale 3D, and let's make it 5 in all its axes. And now I go compile and go save. And I'll just drag in my other cube and I go play. When I interact with this cube, it should destroy. And when I interact with this green cube, it should become a size of 5. So we can use interfaces as another way of communicating across different blueprints. With our blueprint interfaces, we can also add variables to them. So we go back to our BP interface and just select our function. It has an input and an output function. Let's first go over the input function. So I can just go add to add a new variable to it. And let's just call this is true, question mark, and compile and save that. And then if we head over to our BP cube, this first one, we can see it has this is true. We can just drag up here and look for a branch and hook this into here. And if this variable is true, then we'll destroy the actor. If it is false, then we will just print string the word false. And now I go compile and head back to my third person character. And now in our third person character, on the interact, we can control whether we want this variable to be true or false. Let's just make it true. Actually, let's leave it false. And now if I could compile and go play and try and interact with this cube, it's going to say the false message. So with our interfaces, if we want to, we can add variables. We can also add outputs to our Blueprint interfaces. So to showcase this, if we create another function and just call this interact2, and under outputs, just add a new output, and let's just again call this isTrue. And if I go compile and go to my BP cube, and under interfaces, we should see this interact2. When we make an interface have an output, if we double click inside of it, we can control the value of this output. So I'm just going to right click here and promote this to a variable and make this instance editable. And just go compile. And now if I head inside my third person character, instead of calling the interact message, if my capsule overlaps anything, I'm going to call the interact2 message. So I'll just drag off here and look for interact2 message. And we can see this has an output, and we've controlled this output inside of our BP cube with this variable. And let's say if this is true, then we will destroy the actor. So to do that, we can just drag off this other actor and look for destroy actor. And if this is false, we'll do nothing. So I can compile, close this, and select this cube. I'll duplicate it by selecting Alt and selecting it just to duplicate it. And let's make one of them is true and one of them false. And if I go play and I go to the one that is true, when I overlap it, I destroy it. However, if I go to the one which is false, because that variable is false, when we overlap it, we can't destroy it. So that's kind of how we can use Blueprint interfaces. They can just have functions, they can also have inputs if we want them to, and they can also have outputs. Hello. Next, let's go over the final way of making blueprints communicate with each other, and that is by using event dispatchers. To create one, if we head over to our third person character and go to this panel here at the bottom called event dispatchers, and just click the create button, and let's just give this an appropriate name. So I'll just give this test dispatcher. Now, in order to reference and call an event dispatcher, if I just right click and look for the 3 button, when I press the 3 button, I'm going to call my event dispatcher. So just drag it in, and you just want to look for the call button. Now when I press the 3 button, it's going to call this test dispatcher. Although currently this does nothing. In order to make this activate and do something, if we head over to another one of our blueprints, so let's go to this green cube. If I double click and open it up, to reference and call an event dispatcher, if we just right click and look for the event begin play node, event begin play, we're going to drag off here and look for cast to the third person character. In order to get his object reference correctly, what we can do is just right click and look for get player character. This will get the player character that the character is currently playing as, and because we're in the third person game mode, we'll be playing as the BP third person character, so we can hook this up here. And now that we're here, we can just drag off here and look for bind to test dispatcher, and then we can just drag off this event and just drag off here and look for add custom event, and let's just call this swap colors. And I can just drag up here and have a flip-flop. And I'll just drag in my cube and I'll make it swap between 2 colors. So let's look for set material and make it swap between this pink and this blue. And now if I go compile, whoops, if I go back to my third person character, I just need to compile here, and then I should be able to compile here. Sometimes Unreal just does that. So when we press the 3 button, we're going to be calling this test dispatcher. Inside of our BP cube, event begin play, we have casted to our third person character and binded this test event dispatcher to this custom event. So now when my third person character presses the 3 button, it's going to be calling this test dispatcher inside the BP underscore cube 2. Let's just test that this all works. And now if I press 3, we can see that that cube will swap colors whenever I press the 3 button because it's bounded to my event dispatcher. And like with our other Blueprint communication methods, Our event dispatchers can also pass on variable information. So if I just go to its inputs and add a new parameter, we can just call this new parameter. And if I go compile and go to my cube and go compile, we can see it has that new parameter here. And using this, we can control whether we want this to be true or false. Then the last thing I want to show you with event dispatchers is how to make them stop working. So currently at the start of the game, we bind our cube to our event dispatcher inside our third person character. If you ever wanted to unbind it, what we could do is I'm going to have event begin play, and I'm actually just going to move everything a bit up. And event begin play, I'm going to have a sequence. So first I'm going to bind this event dispatcher to my third person character. Then after, let's say, a delay of 5 seconds, we can copy all of this again. Although this time, off of my third person characters, I'm going to look for unbind test dispatcher. And for the event, just hook this up to the swap colors event here. And let's also just add a print string here so that we know when we've unbinded this event dispatcher. And I'll just make this print string say unbind. And now if I go compile and save this and go play, as soon as the game starts, I can press the 3 button to swap my cube's colors. But let's wait 5 seconds. It's unbinded. And now if I press the 3 button, we can see I can't swap my cube's color anymore. So that's how we can use event dispatchers. With that, we've covered all the 3 main ways that you can use blueprints to communicate with each other. Hello. In this next section, we're going to go over how to design some UI for our game. To get started, if we open up the content drawer and just right click, we're going to go to user interface and select widget blueprint. Once we're here, just select user widget and just call this WB_HUD. Once we've done this, we can double click and open up our widget blueprint. And this first panel we're going to see is the designer. And here's where we design how our HUD is going to look. We can design how our HUD will look by using the elements in the palette. The first element that we normally add is a canvas panel. So we just look for canvas panel and just drag and select this into our widget blueprint HUD. Then just add this box, and here's where we're going to design our HUD. So there are many different elements that we can add, but for now let's just add some text. Once we've selected an object inside of our hierarchy here, we'll have this details panel where we can change some of the settings. So I can change the text, what it says, so maybe I'll make this say HUD. I can change the color of this text, so maybe I'll make it red. I can change the font and the size of it, so maybe I'll make this 50. And there are loads of other options that I can play around with. One of the main things you'll need to know when you're working with UI is anchoring. So currently, if I select my text, we can see we have this little white flower in the top left corner of the screen. This is basically going to be where my text is anchored to on the screen. This isn't looking correct, so what we want to do is just go anchor and anchor it to the top middle. This will help ensure that when this HUD is displayed on our screen, it will be in this location. So now we've designed this very simple HUD. If we just go compile and save, I'm now going to show you how we can add this HUD to our game. So to do that, if we open up our BP_third person character, and we can just right click and look for event begin play, and just drag up here and look for create widget. Then under the class, you want to select the WB HUD that we just made, and you just want to right click here and promote this to a variable, and just call this variable player HUD. Then after this, just drag up here and look for add to viewport. And then if I go compile, close this and go play, when I start my game, it will display that HUD that I made. Next, let's go over the different ways that we can dynamically change our HUD whilst we're inside of the game. Then if we open up our widget blueprint, we can just select this text and delete it. And the next thing we're going to do is create a HUD which is going to display the amount of coins that our player character has. So in order to achieve this effect, if we go to our palette and look for a horizontal box, just drag this and place this in the top center of your screen, and also make sure to anchor it to the top center of your screen. Once you've done this, just look for some text, and we want to drag 2 pieces of text inside of our horizontal box. There's also a box called a vertical box, and it does what the name implies. If we put loads of text inside our vertical box, they'd appear on top of each other. Now, within our horizontal box, our text is quite close to each other. If you want there to be a gap between elements inside of boxes such as these, what we can do is just select this first piece of text and go padding, and if I say put a value of 50 in the right, it's going to add a bit of a gap between each of these texts. So you can just do that if you want to have, like I said, a bit of space between each of the elements within a box. Okay, so for this first text, I'm just going to make it say coins. And for this second text, we're going to make this display the amount of coins that our player character has. So if we just go back to our third person character, and we've actually created quite a lot of variables, so I'm just going to delete everything actually. And I'll just delete all these nodes. And what we're going to do is just look for add new variable and just call this coins. And then if we go to variable type, just change this to be an integer so that it's always a whole number. And then if we go to compile and go to our widget blueprint HUD, I'm going to show you two main different ways to display the amount of coins that the player character has. So the first way is if we go to our graph, and this will take us to an event graph, kind of similar to the one in our third person character or in any blueprint. And here we can write some blueprint logic that we want our HUD to perform. And what we're going to do is event construct. And the way this node works is as soon as our widget blueprint is displayed on the player character screen, it will call the event construct node. So it kind of works similar to the event begin play node. So event construct, we're going to communicate to the third person character. So to do that, we can right click and look for get player character. And this will get the current player character that we're controlling. We know that the character we're going to be controlling is the third person character. So what we can do is just drag off here and look for cast to third person character. And this will make a connection to our third person character. Now that we've done this, we can just right click here and go promote to variable. And I'll create a new variable called as third person character. And now if I go compile and go to designer, and I just select this text, and if I go to bind, I can see the third person character variable that I made. And from here, I can reference all the variables inside of the third person character. So here I see my coins variable, and if I just select it, this text is now going to be binded to whatever the amount of coins that my player character has. So if I just change this value to be something like 100, and go compile, save, and just go play. Whoops, so because I deleted some variables inside my third person character, it messed with some variables here. So I'm just going to delete all of this. My bad. So I'll just delete everything inside here. And now if I go play, when my game starts, it loads up this HUD which says coins, and then it'll display the amount of coins that my player character has, which is 100. Nice. And if say I create a new blueprint, so we can just use my BP cube, and if I just select its box collision and scroll down and go on component we can overlap, if this other actor is the third person character, we'll cast to the third person character, and then just drag off here and look for do once. And what we're going to do is we can just get the amount of coins that they have, and if we just drag off here and look for increment int, this will increase the amount of coins that the player character has by 1. And then if I just drag off here and look for set coins, we're going to be setting it so that our player character has 1 more coin than they previously had. And after we've done this, we can just destroy the actor. So I look for destroy actor, and then go compile, save this, and let me drag in some of those cubes. So I have 3 cubes placed on my level. If I go play, I have 100 coins, but let's say I go and select this one, I'll go to 101, then 102, then 103. And the reason it's doing that is because inside of my HUD, When we bind a text, it will update every frame, so it does it very frequently. When we bind a text, it runs every single frame, so you may not want to bind text. So I'll show you an alternative way that we could use to update and display the amount of coins that our player character has. So the first thing we're going to do is select this text and just select it here under bindings and go remove binding. Then we just want to go to the details and give this text a name. So let's just call this coin display, and then just check this is variable button. And then if we head over to the graph, what we can do is drag in our coin display variable that we made. So this is referencing this text, and what we can do is just drag off here and look for set text and just select this bottom one, set text text. And as soon as our HUD is displayed, we're going to make it display the amount of coins that my player character has. So we can drag in our as BP third person character, get a reference to this, and then from here, get the amount of coins that they have, and just connect this value into here. So now when the game starts, it will display the amount of coins that my player has. Next, we need to write some nodes which will make it update when our player character collects a coin. So to do that, what we can do is just right click here and look for add custom event and just call this update coins. And when we run this update coins custom event, what we're going to do, we can copy all of this and paste it here. So when we run this update coins node, we're going to check the amount of coins that my player character has and display it inside of my coins text variable. So if we just go compile and then go back to our BP cube, we make it so that when the player character overlaps some coins, it does this do once, where it'll update the amount of coins that they have. What we can do is just drag off here and get a reference to the HUD variable that we made. So I think we called it player HUD. So look for get HUD. Yep, so we'll look for this get player HUD. And then we can drag off here and call the custom event that we made inside the HUD. So let's call update coins. And we just want to place this after we have updated our player's coins. So we'll place it here. And then we will destroy this actor. So now I go compile and go save. If I just go play, when I start I have 100 coins. If say I go into this block, I have 101 coins, I have 102 coins, then I have 103 coins. So by doing it this way, it's just a bit more efficient. Although if we did it the bind way, it'd just be a bit quicker to do. Although we can do it this way and it'll be a bit more efficient. Next, I want to show you how to remove HUDs from the screen. So to do that, if we head back to our third person character, event begin play, we create a widget and add it to our viewport. In order to remove a HUD from our viewport, what we can do is just right click and look for the 1 button. And when I press the 1 button, what we're going to do, when I remove HUDs, I like to add this node. We can drag in our HUD variable, then just drag off here and look for is valid. And we just want to check this one with a question mark and hook this up here. This is valid node will check to see if the HUD is actually on the screen. And if it is, then what we can do is just drag in our player HUD variable and then drag off here and look for remove from parent and just select this and hook this up here. And now I go compile and go play. When we start the game, we start with this HUD on our screen. However, if I press the 1 button, it will remove the HUD from my screen. That's all for this video. If you want to learn how to create even more games in Unreal Engine, be sure to check out my website. The link will be in the description of this video. On there, I have many different courses which will teach you how to make full games in Unreal Engine, from 2D platformers to melee combat systems to retro FPS games and even more. If you enjoyed the video, like and subscribe, and I'll see you in the next one. Bye!